Hi guys, and welcome back to Physical Sciences for Year 10 of the Australian curriculum. In this video we're going to be looking very briefly at heat and light energy. Now heat energy is basically the energy that you've got with a hot object. So basically it's looking at, more often than not, it's looking at the amount of vibrational energy that you've got. Now that vibrational energy will generate friction. Now heat basically is the movement of that energy. We notice that heat energy moves from areas of large amounts of heat to areas of cold. Now that transfer of energy we term as heat. Okay, so the more energy an object has, the hotter it's likely to be. Now it's radiated away from objects. It can happen in chemical reactions. So when you add magnesium to hydrochloric acid, you'll get heat which is basically given off during that reaction. As we know, heat is generated from any nuclear reaction. We talked about that earlier in nuclear energy. And as a result, that nuclear energy is converted into heat energy. That heat energy can be harnessed, and from there we can then utilize it for other forms. Energy travels through space in the form of heat, and basically it's in the form of infrared heat, and as a result it hits our planet Earth, and as a result we can utilize it. More often than not, heat is a waste energy. So during an energy transformation, it's given off. So for example, in the car, the chemical potential energy is converted into kinetic energy, but you're also going to get heat generated. Now that heat given off actually comes from that chemical potential energy. Unfortunately, we don't want that to happen, but as a result it comes off and it's just released into the atmosphere. You take a light bulb gets hot. Now we want the electricity flowing through a light bulb to be converted into 100% into light, but unfortunately it's not, so we lose some of that energy in the form of heat and it's radiated out. Okay, so heat really looks at the amount of energy which radiates from an object. Now light, on the other form, basically comes in a variety of different frequencies. And on the white light spectrum, which is about halfway through the electromagnetic spectrum, we see different frequencies of light gives us different colors. Now Einstein came up with the theory that light was in the form of particles, although previous knowledge that we had is that light can travel in the form of waves. So that's why when you look at the diagrams below, you can see we've got two different waves there. We've got blue light wave and we've got a red light wave, and you notice that the wavelengths and the frequencies are different. Blue light, very close together. Red light on the same scale is a lot longer. We find red light at the long end of the electromagnetic spectrum, whereas blue light is at the high end of the electromagnetic spectrum. Their wavelengths is the length of the wave going from, generally we look at it going from midpoint up to the top, then back to midpoint, down to the bottom, and then back to midpoint. That's the wavelength. It's one complete wave. Now you can see the wavelength for blue light, very short. The wavelength for red light is a lot longer. Now we don't really need to know this for any form of assessment material. It's more of a case of making sure that you understand it comes in different forms. Now Einstein basically came forward with the theory from his observations that different types of light give off different amounts of energies. He called it the photoelectric effect, and we studied that in senior physics. So basically all we need to be aware of is that light can travel in two forms, wave and particles. They have different amounts of energy and they have different frequencies and wavelength. Often light can be given off from a chemical reaction. So if you burn something, you can see that you've got light which is emitted because you can see the flame. And if you get a spark, there you've got the energy, but it's coming off in the form of light. So really light and heat energy, unless we're using them for their specific needs like light, or you want to heat something up, can be a waste energy during some form of reaction. Okay, so when you think about your energy transformations, always think, can you see it? Can you see something giving off? Then there must be light energy. Or can you feel it? Then it might be heat energy. Okay, well thank you for watching, and join me again and we'll look at the last two types of energy in the next video. Thanks for watching.